Hello. I would like to tell you how do we calculate the partial derivatives. And let me explain the derivatives versus differentiation. So regularly, if we have a differentiation, we typically write down the d in the front. Suppose we have function f and has two variables that's called x and y. We will write in the following format, and then followed by two partial differentiations, one in the with the x, one in the with the y. So we will write down partial f of x while holding y constant and dx. So that's the first variable we have. Second one, what we need to do is we will compute partial derivative of f with respect to y, holding x to be constant and then multiply by dy. So this entire expression, which we call total differentiation, the derivative has to be written in the following format. These are the two derivatives that you can see here. So that's the difference. So differentiation itself is essentially combined with the derivatives multiplied by the variable dx. Similarly for the second term like this. Now I'm going to show you one example. Suppose f of x, y, so this example, 1 equals x times sine y, like this. Now I can directly calculate the total differentiation using this format. So essentially what we need to calculate is the partial derivative here, which means we can take derivatives with respect to x while holding y constant. So this means this term, second term, is going to be constant. So what I will have, partial x over partial y, of the over a partial x and withholding y constant. So this part is constant. So derivative of x is just simply 1. So therefore we have sine y like this. That's a partial derivative. Similarly, for this term, partial y over partial f over partial y, this will be holding x constant, so partial x over partial y, holding x to be constant, then sine derivative is just cosine y. So that's the partial derivative. So if I write an entire differentiation itself, then I will have df parenthesis xy equals sine y dx plus x cosine y dy. So like this. So in this example, which is simpler, you can see the function directly equals x times y. But sometimes we do not have such simpler expression. Let me show you the second one. Suppose I have just an equation, x, y, z, let's say equals 1. In this case, when we calculate partial derivatives, it must be known to you which one we want to compute the partial derivative. For instance, which one we want to consider as a function. Here you see you have f here, but in this equation, we do not have f. In this case, so the problem has to be asked, we want to calculate partial x over partial z, holding y constant. If we have this expression, this means your x is a function. because it's on the numerator. So this is the numerator. So anything on the numerator is a function. The denominator, as you can see, is a variable. Second, what about if we calculate partial x over, or partial z over partial y holding x constant? Then the in this case, z is a function because it's on the numerator. And so the variable will be y. To be more precise, should be x and y. So here it should be y and z. These two are variables. So in other words, if the question you asked, there's no definitive expression like this, then you have to check out which one you were asked for. For instance, if I put x on the top or numerator, then this x will be the function. Rest these two variables are called variables. So let's work out this. So let's work out A first. So remember, we're going to take partial derivative holding y constant. So the y itself is keep constant. So let's get started. We will take partial derivative with both sides with respect to z. Partial derivative with respect to z, both sides. Oh, sorry, this should be z. X, y, z. So that's my left-hand side. I'm sorry, let me rewrite them. It's a little bit bigger font size so you can see clearly. Partial x, y, z over partial z holding y constant. That's my left-hand side. Right-hand side is just simply 1. Of course, it's 0, but let's just to be formal way, we'll write in a similar fashion. So the right-hand side is 0 because 1 is a constant. The left-hand side, y is a constant, as you can see here. So I can pull out a y. So that's the left-hand side, partial z, x times z. And right-hand side is just equals 0. Now remember, we have two terms. One is the x is the function and z. So let me work out this. Partial x, partial x z and a partial z, it has two terms. First, the derivative is holding z as a constant. So which means we're going to write it like this, partial x, partial z, holding z is constant. Remember, when I say holding z constant, it's just a way for me to calculate these two variables. It's nothing to do with the y here, nothing to do with that. It's just holding one term. For those of you familiar with these derivatives, a, b derivatives just equals dA multiplied by b itself. Similarly, a dB like this. So that's what we have here. Exact same. So here I take derivative with respect to z. So the x take with respect to z, that's first term. Second term that I have a holding x constant like this, x. So we partial z over another partial z. So partial z, this is of course 1. So therefore I have partial x over partial z. Now I can put this y back. In fact, this should have a y there. Put y back, and this will be z plus x itself just equal this amount. So that is how we do the calculation directly in this case. Now the second term, partial z over another partial z, this is the 1, so just equals x. So now all I need to do is just plug this term back into the previous equation. Let's call it equation number 1 here, this equation number 2. So plug 2 into 1. So then I will get y. So that's y multiplied by the partial x over partial z holding y constant times z here and plus x this whole thing equals y, equals 0. Now, if y is never be 0, so this should never be 0 because if y equals 0, this will never be 1. So therefore, both sides I can get rid of this y immediately. So the final results is going to be partial x over partial z, y equals negative x over z. So this is my final answer for partial x over partial z holding y constant. And similarly, you can work out this too. So let me show you the answer, final answer, and you can work out after this. So that is the first lecture. So here is the answer, should be partial z over partial y, and x equals negative 0. So that's the final result. So I will show you another example in the next video.